Hello students. Today we are going to start another topic in sciences and it's lights, camera and capture. What is this topic? Let us see. So first and foremost is rectilinear propagation of light. Okay, don't be scared of it. I'll be teaching you this topic in a greater detail today. Let me adjust the color. Okay, yellow will do. So rectilinear propagation of light. What do you mean by rectilinear propagation of light? So rectilinear propagation means uh, in a straight line. Okay, and it's the propagation of light. What this line means is that rectilinear propagation of light means light travels in a straight line. Okay, so let's see the slide further. Do you remember being in school when the teacher projected something onto the screen? Some of the kids would love to make shadow animals with their hands. They would contort their hands and make a giraffe shadow. So it's actually telling you that no, everything is given in summary in this picture. So let's say if you have a steel rod and there is a candle in front of you. So if that steel rod is hollow inside and it's straight, then you can see the candle clearly. But if it has any turns or if it has twists like this, if it is bent at any position and if you look at it, you won't be able to see the light coming from the candle. And that means that light always travels in the straight line. That's why you can see that light, isn't it? Let us investigate further now. What do we understand by rectilinear propagation of light? Hmm? There's a question mark for all of you. What do we understand by rectilinear propagation of light? Rectilinear propagation of light refers to property of light which travels along a straight line without any interference in its trajectory. Okay, so trajectory means the path at which the light travels. One of the examples for rectilinear propagation is formation of shadows, as we have seen previously. Previously, in the first slide, we have discussed a scenario that uh, if the light is coming, uh, uh, if light is coming from window, let's say, you can do anything like with your hands and perform a shadow like that. So when light travels through a medium like air or water, it travels in straight line. However, the path only changes when there is a shift in medium. Okay, so there is some science involved in it right now. You can see this image over here. You can also try it at home. Take a glass jar, fill it with water, and dip a pencil in it. It will not be looking straight. Rather, it will look like this. It's as shown in the diagram. What happens over here? Light is bending inwards because the speed of light is slower in water. Here, the science is involved. For instance, if ray of light travels from air to water, the path of light bends based on change in density. It's also known as refraction. So what happens is this water, just let me change the color of this. Okay, so this water over here, this water is thick, more thick than the air around. So when light is traveling in air, it is traveling fast. Okay, but when that similar light goes in the water, what happens is uh, the path is changed because the speed of light is slower in water. Okay, so right now, because it is traveling in the gaseous medium, air is a gaseous medium, right? So when light is traveling in the gaseous medium, it is at high speed. Now, when it goes to liquid, the liquid medium is dense, it is thick, and the speed of light reduces. And that is why this bend takes place. Okay. Okay, so let's do. You are going to do an experiment, not right now, not right here. You do this experiment and see the results. Okay, do this experiment. So for this experiment, we'll require a shoebox, then black electrical tape, needle and hammer, small thin sheet of paper, and a photo paper. Okay, pierce a tiny hole or pinhole in the brass sheet, then make a hole at the center of bottom shoebox and cover it with black tape from outside, which will be acting as a shutter for your camera. tape the brush sheet behind this hole. Pinhole should be at the center of this hole. Then place the photo paper inside the box across the hole and close the box lid. Now point the pinhole at what you want to shoot. Open the shutter for at least 2 to 5 minutes and keep everything very, very still. Take out the photo paper, but sealed brown paper, and ask nearby photo studio to develop it. So you can ask nearby photo studio to develop it. What this infers to you right now? This is actually a pinhole camera. Okay, a pinhole camera. What it does actually is given over here, but how does a pinhole camera works? Is the theory behind it. So to understand how a pinhole camera works, imagine yourself inside a dark room which allows no light inside. Okay, imagine that you are in a very, very dark room and no light is allowed to come inside. Now imagining a small opening made on the wall that you are facing. So let's say there is a room, you are kept inside it, and there is no light, absolutely dark, and there is a wall which you are facing, and there is a hole on the wall. Now from that hole, light is going to come. Light is coming. You can see that light seep into your room. Light comes into your room. Now the person with the torch moved around the light source. You would see the light seeping in, vary in terms of direction and density. Okay, so and now instead of a room, imagine a small box which has been light proofed, except for a small pin sized opening on the box, like this one, the pinhole camera. Exactly. Pinhole camera is the same thing that we have imagined right now. There is only just one small opening, this opening over here on the brass sheet. And instead of you inside, there is a photographic paper which captures the light rays when shutter is opened. Okay, and instead of you looking at the image of light rays hitting the opposite side of wall, the film inside the box records the image in front of this. So let's say your pinhole camera is facing a tree, so that tree, the image of tree, would be captured, but in inverted form. Okay, but in inverted form. The exposure to light has to occur for a prolonged period because the pinhole opening limits the amount of light entering. What happens is you need to occur it for a prolonged period. For a long period of time, you need to keep that shutter open. Okay, for this pinhole camera to work. No? What actually this shutter means is that the light which is entering has a cutting. Okay, let's say that the light is entering and there is a knob which holds in front of that light. So that is your shutter. When you open that shutter, the light comes in through. Okay. Now, what if we increase the size of the hole? Nice question for all of you. What if we increase the size of a hole? Uh, have you guys wondered what if we increase the size of hole and what will happen to it? If the size of hole in pinhole camera is increased, then the sharpness in the image will automatically decrease. You can see here there is plus image over here. The size of this image, the size of the hole is small, the image is sharp. If the size of hole becomes big, the image becomes very, very blur. The size of hole of pinhole camera increases, then more light enters and disturbs the formation of image. Okay, that's what happens. Pinhole characteristics and its uses. Pinhole camera. So what are the characteristics? A real image is obtained as image is obtained on the screen. Correct? The image is obtained on the screen, isn't it? The size of image obtained is comparatively smaller than the actual object. Yeah, that's the difference. The size of the image which is obtained is small. The image is inverted. Okay, so don't go into this x and y axis. Just remember the image is inverted in pinhole camera. The image can be used in analysis of rectilinear propagation of light. Rectilinear propagation of light means light travels in a straight line. And what are its uses? Image from a pinhole camera may be projected into a translucent screen for safe observation of solar eclipse. Yeah, you can also watch solar eclipse with it projected into a translucent screen, but There are many you should take many precautions before watching any types of eclipses. A common use of pinhole photography is to capture the movement of sun over a long period of time. Yeah. And pinholes are used for surveillance because they are difficult to detect. Pinhole cameras, yes, they are very difficult to detect. Why? Because there is a very small opening, a small hole, and you cannot detect a small hole very easily. Okay, that's why. And here's the thing time for all of you. What is the role of flash in capturing images? You might have used your mobile phones or maybe a camera as well. And there is a very important property of both mobile phones and cameras is that they have flash. What does flash do? Hmm? Let us see. The pinhole camera must be very small to obtain a clear image, as we have seen earlier. A pinhole size, if made smaller, then less light will be received. Okay, as the size of that hole, as you make the size of the hole smaller, okay, uh, the less light will be received at the image plane, isn't it? And if the pinhole is comparable to wavelength of incoming light, diffraction effects blur the image. Now, don't go into that much detail, but what happens right now is if you make the pinhole very small, then the image gets distorted. Okay, a bigger pinhole will allow more light to get in, and so the image will become brighter, but it will also be blurred, isn't it? What happens now is when the flash, the mobile flash, you hit the mobile flash, it increases the luminosity. That is, it increases, it makes to capture more and more light from the same hole. Okay, it increases more light on the object. So let's say this is my object, this is a stick man over here, this is the object, and you have your pinhole camera here. Okay, it has a very small hole. So this hole will capture this whole man, but it will capture it slowly. Okay, once you give the flash, so now here is a flash over here. So it flash what it does, it illuminates the object. Okay, it illuminates the object. It gives it illuminates the object, and because of that illumination, more and more light is captured through the same size pinhole. Okay, and that is why flash is required. So now STEM cards, science, technology, engineering, and mathematics cards. A small notes for all of you. A pinhole camera is based on the fact that light travels in a straight line, obviously, and once the shutter is open, light rays shine to imprint an image on the photographic plate placed in the box. Okay, so that's all for today. Have a nice day. Thank you.